Back again with another video here. Let me just make sure the sound works. You already know I gotta check the sound. Here comes the sound check. There was the sound check. Okay. Yeah, the last video was 2-1, 2-2, 2-3 homework. Yes, it was a lot. It was a lot of problems. It was 20. Yes, here's 2-4. It's also 20. I mean, look, I'm not going to lie to you. You got to practice this, and there's going to be a lot of the same kind of problem. And so my goal here is to show you how to do about half the problems, you know, the old-fashioned, you do it work way. I mean, I want you to know how to do that, but to save a little bit of time, because I don't know who would watch me do all of 6 of the same kind of problem anyways. So to save a little bit of time, I'm going to probably use some alternate methods here, and you can enjoy using those if you want. I don't mind. That's totally fine. So here we go, 2.4. First problem, simplify this as much as possible. All right, we're gonna do it the old legitimate way. So we're going to brushes 3w plus 4w equals 42. When the variables are on the same side, now we did a lot of stuff in class over solving equations, but we did not do any problems that had, well, we did like a very tiny amount of problems that had this scenario. The variables on the same side, you do not need to subtract 3, you do not need to subtract, I'm going to write something real quick, and I'm writing it in red, and I'm telling you as you watcher of the video, that this is wrong. People do this thing where they minus 3w and then they minus 3w. That is super, no, because you just subtracted 3w on the left side and then you subtracted it again on the left side. You can't do that. So if you get in a situation where you're like, yeah, that looks good. No, well, hold on a second. I hope you, if you watch this video, at least remember that I said no a whole bunch of times. Listen, if the variables are on the same side, you combine them like they're like terms, because they are like terms. 3w and 4w is, well, I need to get a brush out, don't I? 7w equals 42. It might be very tempting for you to do some kind of weird subtracting or adding something to both sides. That's completely unnecessary in this situation. So w equals 6. Continue. Okay. Another one, similarly, we got 10w minus 3w. And again, as tempting as it might seem, we don't need to add or do anything to both sides. We just need to combine these like terms. 10w and 3w can combine to make 7w. And divide by 7 on both sides. And w equals 5. I heard some kind of yell outside there. I hope everyone's not dead. I don't know if it was like we're playing and yelling excitedly, or somebody almost touched the hot oven. That's kind of like what I heard. All right, we got 6v plus 3v equals 27, and I'm clicking the button as usual. All right, again, combine like terms. You get 9v equals 27. Divide by 9. Finally, I didn't combine to make 7. All the other ones were like that, and you get 3. Okay, I said I would show you guys a quick way on some of these, but I'm pretty sure those ones were so easy you don't even, the quick way might as well be to write it down, am I right? Alright, now we got some alternate ones. We got ones with the variable on both sides, which is more akin to what we did in class today. So let me write down the full problem here. Oh, it's too big. Alright, anyways, you have negative 5w and negative 12w. Now, here's been my my motto on all these problems. Always get rid of the lesser thing. And you have to acknowledge that lesser means bigger negative. Like negative 12 is less. So that's the thing I should get rid of. So how do you get rid of that? Well, you need to add it to both sides. Although I am going to do this. Oh, heavens. That's terrible. Alright, well, I was trying to draw a straight line down. It's kind of hard. I'm holding this in one hand and writing with the other. I don't have like a hard surface to write on, which probably, you know, could be considered a bad idea. I mean, I'm not going to argue against it at all. Here, let me set up my desk better so I can write on the flat surface. Do you think that'll make a difference? Like, watch it make the biggest difference on the face of the planet. Alright, so 12w gets added here, and 12w gets added here. The reason why I'm doing that is this goes away. Now, the reason why we want to do... hi, Mr. Teacher Man. Yes, hi. Okay, the reason why I want to add the 12 is because when I do that and I add it to the negative 5, it makes a positive 7. And that's nice. We want to work with positive numbers as often as we can. So 7w plus 6 is 62, and now we're basically where we were at on something we did a little bit earlier, the two-step equations. First, subtract 6 on both sides. 7w equals 56. Then you divide by 7. W equals 8. Hey, 3 viewers? Wow! I forgot to mention to the remind that I was doing this. Should I add it on remind? It's okay. If you're here, you're... Whoa, don't hit submit assignment. Sorry. Check. If you hit submit assignment, it's homework. I mean, it's not like it's going to mess anything up for you, but, you know, be careful. All right, another one. This one looks like a lot less negative numbers for me. Okay, so we're going to do... Let me just write out the problem real quick. We have 6y plus 5 equals 8y plus 11. So you got y on both sides, right? Draw the red line down the middle. Oh, nope, it didn't really go much better when I was on a flat table versus holding it. Okay, again, take away the lesser thing, negative 6y. That's what you want to do. Now, if you take away 8y, you'll get some different steps, but you'll still get the right answer. I mean, I know this isn't the problem you got, but if you take away the wrong letter, amount of letter, it doesn't ruin the problem, as long as you take away one of the two options, I guess. You'll just have to work with negatives possibly. I'm doing it in the way I am, specifically so that the result, like this, is positive 2y. I'd much rather divide by a positive 2 later than if I had done it the other way around, which might have made me get a negative 2 later. Okay, I subtract 11 and I get negative 6 equals 2y, and then I divide by 2, and negative 3 is my result. Check. I think there's about 4 of these problems. I can't quite remember what I assigned here. So if I do 2 like this, I should show you 2 the other way. So here's the dreaded other way. And I mean dreaded by, just kidding, it's amazing. I'm going to graph it on Desmos. Negative 3x plus 2 equals negative 10x plus 30. And you can see it crosses at 4. That's the answer. That's the answer to the problem. There you go. I'm going to get it right now. Check it out. Wow, I can't believe it. I could have done all the work, or I could have done this. Now here's the thing. I really want you to know how to do the work. That's why I showed you a couple with the work, okay? This one just happens to be like that. Now, and there's another issue as well. For example, if I typed a problem like this, and the graph doesn't appear, and I zoom out, and there's no graph or anything, that's because it's a special case, and there's no, you know, number answer. It's infinite solutions or no solutions. Although you'll notice they're not giving you those as options. So I guess Alex is kind of, in a sense, giving away the fact that you have an answer that you have to find. All right, I'll do this one on Alex as well. I mean Desmos. I'm so sorry. I'm definitely doing it on Alex. Negative 16 plus 9x. Please note, I am taking all the current letters out and changing them to x instead. And if I zoom out, yeah, here it is, negative 10. And there's the answer. Okay, can you do this on a test? Sort of, sure. I mean, again, I mentioned this in the last video. Will you be asked to show me your work on how to do these by hand? Maybe. Wink, wink. So be careful. It's good to know how to do it by hand. I'm just expediting and saving some time. All right, this one's a little bit different, so I'm going to go back to doing it the legitimate way here and show you a couple of these. So this one's slightly different from the ones we saw a moment ago because it has parentheses to deal with. Now the way you want to do it is first you want to distribute into the parentheses, if there are any. So 5 times w gives me 5w, and 5 times 6 gives me 30, minus 8w. And then now this is something we did see in an earlier problem, and we didn't see much in class though, but it's definitely possible. There's like terms, 5w and negative 8w, on the same side, So please, again, I mentioned this earlier, do not add 8w to both sides. Do not, you know, subtract 5w, something like that. Just, if you want to, like, here, this is not a step you have to write. I'm just saying it might help you do better if you move the like terms together. So you'll notice I moved the negative 8w next to that. That could help you as a step. I know it's extra writing, but it's better to be right than not right, right? Okay, 5 minus 8 gives you negative 3. w. Now we do it like a two-step equation. We subtract 30 on both sides. 12 minus 30 makes negative 18. Negative 3w's on the right. Divide both sides by negative 3. And you get regular 6 equals w. And I know I mentioned this earlier. Could I have graphed this on Desmos or whatever? Yes, of course. But I've got to show you some by hand. That way you know we're all legitimate here, right? Next problem. Hold on. Yes, sorry, I got a message from the teachers being upset that the email doesn't work at home. So, FYI, if anybody emails me, I don't know when they're going to fix it. It's, good job our school district. We're doing great this year on technology. The emails are not working at home. I can access it quite easily at school, but I can't at home, and that's an issue because there's definitely some emails I wanted to respond to today. I had to go home. It was 4:30 already, and I'd been working up until that point. All right, another one. We'll do it legit. We'll first distribute. 4 goes to 4v, and negative 28. 4 times 7 is 28. Sorry, my handwriting's getting pretty bad here. So we got 4v minus 28 minus 7v. That's a little gross. Here, let me try and write nicer. And while I'm at it, I'll move that 7v next to the 4v, just like I did on the previous problem. So these 7 and 4 together make negative 3v. I'm really sad that my two examples I have here both had negative 3 as the number they equaled. That's just coincidence, not like it's going to happen to you. If it does happen to you, great. I guarantee you if everyone I taught watched this video, at least 2 or 3 people would say, hey, that's a problem I got, and get like a free answer out of it. I mean, it's not going to be the case for everybody, but I know somebody out there's probably got this problem. Alright, I added 28 to both sides and got 3. Then I divide by negative 3, and this causes my answer to become negative 1. Hooray, another correct one. Hold on, let me check this. Okay. Yes, people mad about email still. Okay, good. Well, isn't it just fun when you're an adult and you're just like mad you can't actually do work at home? What? Who wants to do that? All right, another one. This is the same as what we just did. I'm gonna continue doing these by going back to this method. Hey, this one already has x as the values, so it should be even easier for me. What's also nice about this method here, I mean, I'm not saying this is the best thing to do, but it also at least saves you from having an accident, because there's somebody out there who might accidentally add 7x and 2, which would never be a step you'd want to take doing it by hand. But if you type it in this way, I mean, it forgoes all the mistakes you could potentially make. You just type in exactly what you see, and it says 9, and you go, okay, it's 9. There you go, easy points, right? Continue. I think there's going to be another one of that type. Yes, another one with distributing. Just don't forget to change it to x. I've had a lot of people go, Mr. Parsons, hold on, I'm having a thought here. They say, Mr. Parsons, I couldn't get this to work, but then they show it to me and they're not using the right variables. Okay, I was going to do this on the graph, but this one is a little different, so I think it's worth doing on paper. And you're probably like, hey, how do you know it's a little different? Looks the same as everything else. Well, everything else as we were doing it, after we distributed, had variables on the same side. This one does not have variables on the same side, so I think it's worth doing separately. So 4w is what you get when you distribute, and 4 times 9 is 36. And then on the right you have 2w plus 32. So this is what I was saying. On all the other problems before this one, we had 2 variable things, but they were on the same side. So here we have on opposite sides. So we have to do what we did on... Wait, did we have to do this on any other problem yet? I don't know. We subtract 2w on both sides. Hold on. I haven't been doing this for a while. Let me do this on this one. Draw the line. Subtract 2w on both sides, and that gives me 2w plus 36 equals 32. It's a two-stepper from here. We subtract 36. You get 2w equals negative 4. U divide by 2, and W equals -2. Sorry, that handwriting's getting sloppy. Okay, continue. I get the feeling this will be the other one of a similar type. Oh, should I do it legit? Okay, I will. I gotta show you as many of these as I can. Okay, so we got -6W plus 39. 9W plus 1. I'm distributing on this right side, actually, so the left side will remain as is for now. And the right side will become 9W plus 9. Please, so many people, when they do this thing, when they multiply by 1, they just write 1 again. Multiplying by 1 doesn't give you 1. Multiplying by 1 gives you whatever it is you just multiplied to 1. Only 1 times 1 would make 1. Well, among some other things, like reciprocals and stuff too. But if you're multiplying something to 1, you're going to get that number. So 9 times 1. Okay, whatever. I'm done complaining. All right, and then we're going to follow some more steps. We've got variables on both sides here, just like the last problem. Again, remove the smallest thing. -6 is smaller, so I'd like to get rid of that by adding. 39 equals 15W plus 9. Subtract 9 on both sides. I get 30 equals 15W. Divide by 15. 2 equals W. Oh, yeah, you can't see that. I guess I'll skip this over. There you go, 2 equals W. I'm sure you were so thrilled to see that. Oh, did I actually set this up right? Oh, okay, fine. 2 equals W. Yes, sorry, the face covers the corner. Please something different. No, it's the same. Okay, well, fine. If it's the same, then we'll just do it the other way. First, we need one of these. Okay, so 7x minus 5 equals 4x minus 20, and it crosses through 5. I mean, you know, after doing those other ones, I ain't gonna lie, like, this is so much more convenient. If you're doing your whole homework like this, I mean, I'm not gonna blame you. You are allowed to, okay? Oh, look at all these words. All right, words are good. So it says, 2 pools are being filled with water. To start, the first pool has 1,900 liters, and the second pool has 1,372 liters. Let me full size this. Water is being added to the first pool at a rate of 31 liters per minute, and water is being added to the second pool at 42 liters per minute. So what these problems are asking you to do is 3 parts. Part 1, you need to write an expression for the pool, the first pool of water. So the first pool has 1,900 liters in it, right? And it's adding 31 per minute. And it says, make sure you write the right thing. I know M is very tempting, but it says let X be the number of minutes. So 31X is what I got right here. So the amount of water in the first pool is 1,900 liters. That's what it says it started with. And I add 31 per minute, right? The second pool of water has 1,372. And they're adding 42 liters a minute. Now here's the thing. We don't need to actually solve the problem, which we could. We could with our technology that we have, or our knowledge we have. But they don't want you to solve it. They want you to actually figure out what equation you would need to put together to solve. So, like, here's the deal. Think about it this way. One pool of water has more than the other, right? But the second pool that starts with less is gaining it at a faster amount per minute. So what will eventually happen is, at a certain amount of time, the second pool will actually end up getting the same amount of water as the first pool, and then start getting more than it, right? So what they want you to do is write an equation you would use to show when the pools would have the same amount of water. And it's quite simple. I mean, I just talked about it a lot, but the simple thing is this. You take your first equation, and you say, I want to know when that's equal to my second equation. Now again, we don't have to solve this, okay? They just want you to set it up. So they want you to set up the left side of the equation based on the words, the right side of the equation based on the words, and then put them together to ask when they're equal to each other. On this case, they're asking when they're equal to each other. I'm pretty sure that's what you'll see. You are under no obligation to solve the problem, but I am going to solve this problem just to show you. And now I'll even use the quick way here so I can save a little bit of time. 48. So the number I got right here would imply that after 48 minutes of water filling, one pool would be equal to the other. You didn't have to get that answer. I just wanted to show you that it's a thing. Okay, I'm going to guess there's a second one of these. Hooray! Amount of money in Frank's account. Okay, Frank opened an account with 590, and he's going to take out 35 per month. Now, you got to be careful. He started an account with 590, and he's going to take out 35 per month. So we need to subtract 35, and I'm using x again because it says let x be the number of months after today. And then Leah's account is at 790, and she's going to take out 55 per month. Perfect. So slightly different than my last problem. We have an amount of starting, and then you take away from that each month. So I did minus instead of plus. And then, of course, when do we want to know when the accounts have the same amount of money? Well, that's when the first one equals the second one. There you go. We don't have to actually solve it. Oops. We don't have to actually solve it. So in this case, I'm not going to. I know I did on the last one for fun, but in this case, you don't have to actually solve it. Just have to set it up. So again, the goal of this type of question is, can you look at what they're telling you in terms of like who's got what, who's taking out what, who's losing this or gaining this, or etc., and then like writing some statements about them. I'm very happy if you can at least put the first two things together. The fact that you set them equal to each other is kind of trivial at that point, I think. But now that if you're watching me do this problem, you're like, oh, I'm just going to do that on mine. Doy. Alright, 16. We got ourselves some fractions. Ooh-wee. Now, I do want to show you this. I'm going to do this on Desmos. Just to see what happens here. 7 thirds equals negative 6. There's a grumpy kid out there. There you go. So I graphed it on Desmos, la-di-da, and I get this number right here. Now this is why I did Desmos. I didn't know what the answer was. It's negative 1.279. If I type negative 1.279 into Alex right here, it's going to tell me I'm wrong. The reason why is it wants a fraction. But I don't know about you, but I'm pretty sure off the top of my head I'm not confident in what 2.79 is. In fact, Desmos here always rounds the third digit, so it could be 2.86 repeating. I don't know, and this is just what they rounded it to. I have no idea. So like doing this on here is not great. Now you can use it to check that you have the right answer. So for now, I'm just gonna leave this right here, and I'm gonna come back to that when I think I have the right answer. So I will do the right answer the legitimate way. Now that's not gonna say I'm not gonna use Desmos to get some of the answer pieces while I'm doing this. So 5 thirds W minus 7 thirds 6 fifths W minus 6. Okay, so first we got to get rid of W off both sides. Now, the negative 6 fifths I want to get rid of because it's negative. So I'm going to add 6 fifths W and add 6 fifths W. So that cancels out on the right. Now, here's the thing. 5 thirds plus 6 fifths, this is why I said keep Desmos open, because 5 thirds plus 6 fifths, I mean, we could definitely use Desmos for that. I encourage you to. Now, look, it's giving me this decimal stuff here, but you can click this and get your answer as a fraction. I can't do that when I'm using a graph to solve it. It just doesn't give me that option. That's why it kind of stinks, but whatever. But as I'm doing it by hand, I get 43/15. Okay, cool. So that's a number. 40... Wait, did it say 43? Yeah, 43/15, right? I was like, is it 45/15? No, 45/15 would have reduced. They wouldn't have said that. Okay, and we get minus 6. Okay, great. Now we need to do the normal stuff. We need to add 7 thirds to both sides. Add 7 thirds. And if you're looking at this going, dude, Mr. P, I can't. Negative 6 plus 7 thirds? I know. Use Desmos. Negative 6. I'm using Desmos. Like, I don't want to sit there and work that out. I mean, I could, but I'm trying to save some time here. Negative 11 thirds. Okay, so what I end up getting here is I get 43/15 equals negative 11 thirds. Because that's what I get when the 6 and 7 thirds combine. Oh, I forgot to put a W here. Okay, so now to get rid of 43/15, I need to multiply both sides by the reciprocal, 15/43. 15/43. And the result is I get W only on the left. And then this whopping number, well, before I get a whopping number, 3 and 15 can reduce to 5 over 1. So 11 times 5 is 55, and 1 times 43 is 43, so negative 55 43s is my answer. Now, if you're working out a problem like this, and I'm not going to lie to you, hey, if you're watching this video, thank you. I'm always going to thank you for watching this video, but I'm also going to let you on a secret. I don't think I put this on the quiz. It was pretty tough. I mean, I want you to practice it. You never know when you're going to see it, but I didn't put it on the quiz because, I mean, I'm trying to give you a little bit of, like, not too much stress with this fraction stuff. Now, we'll say this, though. I got negative 55 43rds, so what I could do is I know Desmos, like, the graph gave me this number, 0.1279. So on the calculator, type negative 55 43rds and confirm that that is close to what you got. You'll notice there's extra stuff here, right? That is not what this says. But this is like rounded correctly. 279. I guess it was 2791 if you were going to round it one more step, but it cut it off. So what are you going to do? So I'm pretty sure this is the right answer. So I'm saying the thing it crosses on Desmos is kind of only good if it's a whole number or a negative whole number, or if it's going to be some kind of decimal that's easy to tell, like 3.5 or something like that, right? In this case, it was not nice answers. Oh, good, I only put one of that. Weird that I put it right there. Okay, I don't think I intended for that to go right there, but whatever, it's in the middle of it. All right, first, complete the story below so it can be represented by this equation. Okay, so they gave me an equation, and then they give me some sentences, and they want me to kind of figure out a story that makes sense for it. So I see 12 plus 17x, and then I see 20x. Now, here's the thing. The x's represent the price you pay for something. Like, apparently, if I'm reading the word, somebody's going to buy some pizza, right? So I'm guessing he's probably buying $17 per pizza, and then maybe $20 per pizza. But in addition to the $17 per pizza, there's also some kind of $12 extra amount that you got to pay for. So it looks like restaurant A charges $17 per pizza, and there is a $12... Oh, well, let's see what the options. Delivery charge or discount? Oh, I see. So they want me to choose between what makes sense here. Well, the 12 is being added to the thing, so delivery charge. Now, if this had 17x minus 12, I would have probably gone with a discount, you know what I mean? Restaurant B charges $20 per pizza, and no other charges or discounts. Super. $12 delivery charge. That's insane. All right, whatever. The total cost with all charges and discounts is... Well, I don't know. How do we know? We got to solve it, right? So the total cost with all charges and discounts is blank. Wait a second. 3, 4. Wait. Oh, the same for two restaurants. God, I'm so dumb. I'm sorry. I was like way overthinking that. I'm like, wait, what do they want me to say here? The reason why they're saying the total cost with all these charges is the same for two restaurants is that's because they set them equal to each other. Duh, I was so overthinking that. So the only reason why I would say more for restaurant A or more for restaurant B is in the future we're probably going to see problems with greater thans and less than signs. That's what those would be applicable for. I was trying to explain in my head what was not right about this. So it's $17 for pizza, and there's a $12 delivery charge, and then $20 per pizza, there's no charge, and we set this equation up to show when those costs are the same at both restaurants. Although you do need to find the answer to this here, so your choices are do it by hand, or do it on a calculator or whatever. Look, calculator's right here. Ooh, so tempting. No, I'll do it by hand. I'll be a legitimate guy, I guess. Not to mention, the steps are pretty straightforward. So one place is $12, and it's $17 a pizza. That's a plus sign, mind you, there. That is... Ugh. I'm not erasing it. And this is $20 a pizza. So we're going to subtract 17x on both sides. You can't have x's on both sides. And you get 12 equals 3x. Divide by... Oh my gosh, pen. Please, pen. Please, pen, don't do this to me. 4 equals x. So x equals 4. They didn't actually ask a follow-up question. What is x? What does x mean? X is apparently the amount of pizza they bought. That's it. So if they were to buy 4 pizzas at $17 a pizza with this extra fee, that'd be $80. And if they bought $20 a pizza and they bought 4 of those, that'd be $80 also. So they're saying when you buy 4 pizzas, no matter what place you choose, you pay the same amount. Now, does one place give you a better deal when you start buying more than 4? Yes, like the $17 one, right? It's less per pizza, so you'd actually start saving money there if you bought more than 4. $17 pizza and $20 pizza. That's some pretty fancy pizza. Oh my gosh, we're at 30 minutes. I was kind of hoping this would go faster than my other one, but we're almost to the end. All right, another one. We got 16x minus 12 equals 14. So at store A, it apparently charges how much per copy? Now, they're tricky here on me. They have 16x minus 12 on the left. That's not store A. That's apparently store B, because here it just says this much per copy, no other charges or discounts. They're tricking me. They want me to talk about the first side, but it's actually the second side, $14. Store B charges $16 per copy, and there is a $12 discount because it subtracts 12. So $14 per copy on this, $16 per copy, $12 discount. The total cost with all charge and discounts is the same for 2 stores. I get the feeling that no matter if you're doing these problems, you're going to be choosing the same, right? And then you got to solve it. Oh, do I really want to go all out and try solving this? Can I just tell you it's 6? Will you trust me on that one? No, you won't. You won't trust me on that one? I can't believe you. Are you sitting there and saying to yourself, no, I'm not going to trust you? Even though this is not the same problem I have, I want to see it. Here you go. Crosses at 6. Okay, I did the quick way here. Although if you are watching this and that happened to be your problem, then I guess fine. Isn't that great that I did a little extra? Oh, look at all these words. Okay, no, the secret here is you just need to, well, so we've done a lot of this here. So hold on, let me cut back a second. 14 was it? Yes. So on problems 14 and 15 and so forth, we had all these problems where we wrote the 2 sides of the equation and set it up, right? And then on 18, we did, and 17, we did the reverse of that. We got the equation and then explained a story that makes sense for that, right? On 19 and 20, we're putting this all together here. We're going to read the entire story, set up probably 2 sides of an equation, and then solve the whole dealio at once. Okay, easy there, Desmos. Whoa. Okay, here we go. So let's begin. A small publishing company is planning to publish a new book. The production costs will include a one-time fixed cost, such as editing, and variable costs, such as printing. There are 2 production methods they could use. With one method, the total fixed cost is $16,352. 16,000. I am going to lose my mind on this pen. 16,352. And then the variable cost will be $20.75 per book. So plus $20.75 per book. We'll call books X. Guess you could probably use any letter. Okay, then at the other company, so I'm going to put an equal sign, and I'll explain the purpose of an equal sign in a moment. The other company wants 77,802. Good grief, that's a lot. But wait, don't worry. There's a reason for that. So 802. Oh, you didn't see that. 802. And they want to charge $8.25 per book. I am so sorry I did not fit that very well at all on the screen. My apologies. Hey, spoiler alert, if you're going to use the calculator for this, you could type all this in, with one exception. Desmos will be very upset if you use a comma, so please don't use a comma. So let me rewrite this more beautiful. I did a bad job. So here we go. 16,352, 2075x, 77,802, 825x. Okay, great. Okay, so we've done a lot of this stuff already. We've solved problems like this. These are just big numbers, and second of all, it's got some decimals. Whoop-de-doo. But we solved stuff with the variable on both sides tonight, so just keep doing what you got to do. Minus 825x on both sides. Oh, I didn't explain it. So this other company has a clearly much higher cost, 77,000 instead of 16, right? But they do charge you a lot less per book that you make, so eventually you'll actually get a better deal with them. You just have to probably buy a whole lot of books, right? We're going to find out how many books it takes to get to that level. Oh, whoa, 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 whoa. Don't do that. Okay, 2075 minus 825 is 1250. 77802. Okay, now we've got to move numbers. 16352 needs to go away. So 16352. So I'm going to get 1250 x equals, yikes, 6, 1, 4, 50. Oh, you can't see that too hot. Let me scoot it over just a smidge. There you go. So 77. So 2 minus 2 is 0. 10 minus 5 is 5. 7 minus 3 because I borrowed. I was doing that like mentally, I guess. All right, then the final step is I got to divide by 1250 on both sides. I'm just going to put 12.5. When you divide by 12.5 or 1250, you're really doing the same thing. All right, I didn't use Desmos yet, but now it's time. I can do some levels of math, but 61,450 divided by 12.5, that's beyond my pay grade. 4,916. What a problem. X equals 4,916. Perfect. 4,916 books. I don't think Desmos would get mad if I put a comma. I mean, Alex wouldn't get... Desmos would get mad if I put a comma. Alex, I don't think will get mad if I put a comma here as part of the answer, but I don't think it's necessary. Check. Did I get it right? I got it right. Okay. Honestly, after that much problem, aren't you the same as me when I say I'm like nervous that it's not going to be right? Like you do so much problem, you're like, dude, no way after all those steps this is going to be right. I guess it was. It is what it is. Okay, next. The container that holds water for the football team is 1/5 full. After pouring 14 gallons of water, it is 7/10 full. How many gallons can the container hold? Okay. What is this problem? I don't remember assigning this. Okay, it's a good one. We've got to set it up, right? So here's the deal. We have 1/5 full of a tank, right? Plus, they add in 14 gallons, and that makes it now 7/10 full of the entire thing. Now here's the deal. I'm gonna do a little extra on this one. I'm gonna write a first thing that says x equals, and I'm going to describe what x is. The full container, the full container. X is the full container, like how much the full container can hold, right? So what we're saying is this: 1/5 of the full container, so 1/5 of x, plus the 14 gallons of water they add, makes 7/10 of a full container. So that's the setup on that one. So 1/5 of the full container, so 1/5 times x, plus 14 gallons of water, now makes 7/10 of what the full amount could be. That was a little tricky to set up. Okay, then we're going to minus 1/5 x on both sides. I can mental math this one. Go me. 7/10 minus 1/5 is 1/2. How do I know that? Because 7/10, 1/5 is the same as 2 out of 10, because if I double the 1 and double the 5, it makes a common denominator. So 7 minus 2 is 5, and 5/10 will turn into 1/2. It's calculator work. Okay, then to get rid of the 1/2, we're going to multiply by the reciprocal, which is 2. And that makes x and 28. So the full thing is 28. That's a good problem. I like that problem. That I'm gonna say I know you're probably sitting there going, so much problems, so many things. Out of all the problems I did tonight, I honestly feel like that problem was the most likely thing you'd see on a standardized test. That seems like just the problem they'd put on there. They always put something like that. They can't give you the easy one. They got to give you something weird. All right, I thank you for being with me. This is 40 minutes of video, and I haven't even gone over the problem types yet. Now, here's what we did today. We did a lot of stuff. We had problems with the variables on the same side that you combine first. We had problems with the variables on both sides and work them out a little differently. Hold on. Probably 7 was a bad example. Okay, we had problems with the variable inside a parenthesis that needed to be distributed to and then combined together, either on the same side or on opposite sides. I think 10 or 11 was on opposite sides. Nope, those are the same side. Distribution on same side, distribution on opposite side. So a little mix of everything. And then we had problems, I think 13. This one had distribution on opposite side. Okay, cool. There's more of those. We had problems where we were given scenarios and we needed to write equations that made sense for the scenarios and then confirm when the equations are equal to each other. We had problems where you were given an equation, not the scenario, and you needed to make the scenario. So we had problems where you got the scenario and you make the equation, and some where you got the equation and you make the scenario. And then we had problems where you do it all. You do the whole thing. You get the scenario, you make the equations, and then you solve the equations. So a whole lot there. Woo! Okay, that was a doozy. Thank you for sitting through that. Or, I mean, does anyone watch it to the end? Who even knows? I gotta go on those YouTube, videos and YouTube statistics and let me see when most people quit the video. Probably 3 minutes in. It is what it is. All right, thank you. That was a long one, but I appreciate you working your way through it. Okay, I will see you on the next one. Bye.